so that the printed area is maximum. That's our starting point. So we have to find a function for the printed area that we need to maximize. So let's say we call it S again. I think Eric is okay. I hope he's not. Okay, so can anyone give us the printed area?
X minus 2 times y minus 3.
Perfect. Indeed, parentheses, x minus 2 times y minus 3. Do we understand this? Right? So this is the width, which is x. We subtract 2 inches, 1 and 1. And then from the height, we subtract 3 inches because we have 1 and 2 at the top. So this piece is x minus 2, and this piece is y minus 3. The product is the area of the printed piece. Is that okay? Greg, is this okay?
I'm not understanding how.
Okay, so please ask. So this is x. If from x I subtract 1 and I subtract another 1, then I get this width, which is x minus 2. And then in order to get this area, this length, then I have to subtract 1 and 2 from y. So this is y, and this is y minus 3. 1 here and 2 here. So then x minus 2 is the width of the printed area, and y minus 3 is the height of the printed area.
Okay, gotcha.
Everyone? Everyone? Questions? Okay, so let's distribute. We don't like it because it has 2 variables, right? So we have to make sure that we somehow lose one of them. So S equals xy minus 3x minus 2y and plus 6. But we are given the area of the poster. We know that 180 is xy, or xy equals 180. Okay. Yes, I already see that I can replace this by 180, that's fine. So this goes away, it's 180, but I also have to remove this. Is there a way of removing y? Yes. So from here, I solve this equation for y and get 180 over x. So now when I put all the pieces together, this indeed becomes a function of x. How do I write it? So this is going to be 180, because that's what we see here, plus 6, 186, minus 3x, minus 2, and I replace y by 180 over x. So x times y was 180, and I added 6 to it. I copied negative 3x, I copied negative 2, and I replaced y by what we just determined it to be, right? 180 over x. Everything okay so far? Yes? Yes, everyone? Yes? Okay. So then we continue. I simplified a little bit. 186 minus 3x minus 360 over x. Good. So now we're happy because we have the function. And we proceed by finding its derivative, its critical number or numbers, and then we determine, we show whether it gives a maximum or a minimum by studying the sign of the first derivative. So what should I continue with then? Yes, very good. So s prime of x is negative 3. Be very careful now. When we differentiate 1 over x, we get negative 1 over x squared, but there is a minus in front, so it's positive 360 over x squared. Again, we have to find the least common denominator, so we get negative 3x squared plus 360. Yes, I would factor out negative 3 and get x squared minus 120. So we found the derivative. Now we have to proceed with finding the critical number or numbers. So critical numbers cannot come from f prime being from s prime being undefined, because if x is 0, then the function doesn't exist either. So Critical numbers can come only from S prime of X equals 0. And that can happen only if this quantity is 0. Only if x squared minus 120 equals 0 or x squared equals 120 and we take the square root. We will get plus or minus, but it's not accepted. X cannot be negative. So 120 is 40 times, it's 4 times 30. So this is 2 the square root of 30 centimeters, and I'm going to cross this out, it's only positive. So we determined x. That's good, but it's not sufficient. We have to show that this indeed gives a maximum area. We don't know that. Printed area. We don't know that yet. So here is our derivative, and I will refuse to plug in anything in this because they're positive. So when I plug in 0, I get the positive answer. So this is positive. And when I plug in 10,000, this will be negative. So this is typical for a max. However, I only determined the width of the poster. I have not determined the height, or y in other words. But this is definitely a maximum area. I can also determine the maximum area, but let's find y first. So y equals 180 divided by 2, the square root of 30. So that is going to be the height of the poster. So I will simplify. So from here, y equals 90, the square root of 30 over 30. So then y equals 3, the square root of 30 centimeters. And now in order to find the maximum area, I just have to multiply x by y. And that's all I need to do. Of course, minus 2 and minus 3, of course. So let me copy the area one more time. With just x or both, it doesn't matter. X comma y. Why not? So it's x to the square root of 30 minus 2, and 3 the square root of 30 minus 3. So that will be the maximum area. So if I multiply, let's see what happens. The exact will be 6 times 30. Of course, it's 180. We knew that. And this is minus 6, the square root of 30, minus 6, the square root of 30, and of course plus 6, we knew that. 186 minus 12, the square root of 30. This is the exact, and in centimeters, I think it was, no, it was inches, right? Yes, sorry about that, inches squared. Inches squared. Any questions on this problem? Yes, please.
How do you get 3 times square root of 30?
Right. So let's go back. So it is 180 over x, correct? So I simplified first by 2 and I got 90 over 1. So it's 180 over 2, it's 90, correct? Then I rationalized. I have the square root of 30 in the denominator, so the square root of 30 over the square root of 30, but when I multiply these two, I get 30. And then I simplify 90 by 30, and I got 3. Is that better? Perfect. So far, not too difficult. Would you agree? Yes, please. Right, go ahead.
To find the left side for x from the 0.
You mean to find the sign?
Or,
To find the sign here?
yeah.
Very good.
Did
Let's
you
take a
find
look.
0 for the,
Yes, but not in the denominator. I did not plug in anything in this piece.
Right.
Because I can't.
so
But
you-
I can plug in 0 here, and -1 times -120 is positive.
Okay. Alright. Yes.
And then when I plug in here like a billion, of course, this will be positive, 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 but there is a negative in here, so I have negative.
Okay, gotcha.
Better?
Yep.
So I will only worry about the sign of the quantities that could be positive or negative. If the quantity is only positive, I don't even bother with it.
Okay.
So it's gonna be a waste of time. Okay. Any questions? Any questions? Okay. There's a totally different type of problem. A cylindrical can without a top is made to contain V cubic centimeters. Anything of liquid. Find the dimensions that will minimize the cost of the metal to make the can. So a problem like this, you cannot even plug it in anywhere. You don't have any numbers. Okay, so a cylindrical can without a top is made to contain V cubic centimeters of liquid. Find the dimensions that will minimize the cost of the metal to make the can. Okay. Let's say that this is a can, and let's suppose that it has a base. It's not a can, it doesn't have a base, but just imagine. Okay, what is the volume of a cylinder?
pi r squared times that.
Very good. Area of the base times the height. But what about the surface area? Plus the base. One more time.
2 pi r
The
squared
circumference times the
plus
height times the height.
the surface
Base times height plus the
area.
base
Oh, yeah.
plus the pi r squared, of course. But just the lateral area, 2 pi r times the height, right? The circumference, 2 pi r times the height. Of course, we have to add the pi r squared, which is the base. Okay, so let's start. So this is problem 37 on page 333. Here is the can. Here's the radius. Here's the height. The volume is in cubic centimeters. And we want to minimize the surface area, or the metal used. The quantity of metal used to make the can. So one more time, how do I write the surface area without the top? Area of the base plus the circumference times the height. 2 pi r times h. Now the volume we know is the area of the base times the height. Pretty much the same type of situation that we've seen before. I have a function, but it has two variables. I'm given this is known, although it's not a number, this is given to us. So I can eliminate that h, and that's my purpose. So from the given information, we can solve for h. So let's solve for h.
Volume of the pi r squared.
Thank you very much. So we're going to plug it in. So then S now is indeed a function of a single variable. It depends only on the radius of the cylinder or the can. Nothing else. So then plug it in. Pi r squared plus 2 pi r multiplied by v over pi r squared. And yes, we have to simplify. So I'll simplify by pi, and I'll simplify by r. So the simplified form of this function is pi r squared plus 2v over r. Yes, Brett, please.
How do we know we already had H? Or why did we solve for H system?
Because I have a function with r and h, and I don't know how to differentiate the function of the variables. These are not related rates. R and h are not function of time.
Oh, okay,
So I need to make sure that I have a function with only one variable.
okay,
They are not changing. H is fixed, R is fixed.
okay,
So nothing changes, the volume doesn't increase, the radius does not decrease, there is no movement here.
okay,
So when I won't be able to differentiate if I have a function of two variables.
okay.
Not in this class yet. So is that clear?
Mhm.
So we replaced h, we got a function of r only, and this is simplified. We have the function now, what would be the next step? Yes, I have to differentiate. So s prime of r equals 2 pi r minus 2v over r squared. V is fixed, 2 is fixed, of course. So I do have to find the least common denominator. I will factor out the 2. It bothers me. It's a waste of time, just noise. So this is pi r cubed minus v. So I pulled out the 2 from both terms. So I have pi r multiplied by r squared, and then minus v. Everything over r squared. This is the derivative of the surface area, or the material used, if you want, to manufacture the can. So then now, what do I do?
So,
Yes, and only numerator can be 0. So when we set s prime of r equal to 0, we get pi r cubed minus v equals 0, or pi r cubed equals v of r cubed, or r cubed equals v over pi. What does that mean? How much is r? It's the it's very good indeed. So r equals the cube root of v over pi. And you can say prove it. And I'm going to try to prove it. Of course, this makes no sense when it comes to finding the sign. So if we disregard that, because I can't plug in 0 in the denominator. So let's plug in 0 in the numerator. So when r is 0, what is the sign? Of course, I'm sorry, I should have put 0 here, of course. So when I plug in 0 in r, what do I get? Indeed. Indeed, the volume cannot be negative, so with minus in front, it will be negative. Okay, so now outside of that, so let's see the radius is as big as v, okay, which is not possible, but definitely this is much bigger than the cube root of v. So let's plug it in. So then we will have pi v cubed minus v. What type of number is pi v cubed minus v? Definitely positive. So this is definitely a minimum. If you deviate from the radius of being the cube root of v over pi in any direction, even a tiny bit, you're not going to get a minimum surface or material used. So the question was asking us to find the dimensions that will minimize the cost. So we can find the minimum if we want to, and we determined r, which is the radius, but we have not determined the height. Because they're asking us to determine the dimensions. So where was the height? Like 5 pages ago, right here. So h. was v over pi, and I have to square this. That's pretty ugly. And the dimensions were given to us centimeters. So this is in centimeters. Don't forget to write the measurement unit. Yes, I should work on this and simplify it a little bit. If you say yes, I work on it and simplify it. If you say no, then we can do it as next. What I need to do is rationalize with the cube root of v over pi, top and bottom, and try to simplify it if possible. Is that a go, or we look at the next problem?
Do we have to for the test?
Yeah, but I will try not to make this ugly. It really is ugly. But yes, yeah. So if you say yes, we'll work on it. You want to work on it?
Sure.
Let's work on it. Very good. Okay, so let's try to simplify it. This is not fully simplified. It's not rationalized. So here I will change it basically into the cube root of v over the cube root of pi, and I will multiply by the cube root of pi squared over the cube root of pi squared. So the denominator is pi, so r equals the cube root of pi squared v divided by pi. So this is better. So I separated the cube root of v over pi to the cube root of v over the cube root of pi, and I rationalized with the cube root of pi squared and the cube root of pi squared. That's why the denominator now is cleaned up, has been just a fraction, just pi. And the numerator is the cube root. So I can already plug this in and square it as dx. So maybe that's going to be easier. I doubt, but same thing. So now let's work on h. So this is in centimeters, and no one can further simplify this. So now on h, I have v, pi, and now I'm going to square this instead of squaring the original that we have here. So I have the cube root of pi to the fourth v squared over pi squared. And I simplify a pi, and this is pi v over pi and the cube root of pi v squared. And then I will rationalize that. Pretty ugly. So then h equals v over, this is the cube root of pi and the cube root of v squared. And we rationalize by the cube root of pi squared and by the cube root of v. So the cube root of pi squared and the cube root of v squared. And now the denominator becomes pi v. The numerator is v. And then the cube root of pi squared v. So we cannot do anything else. This is it. How nice. Look at that. Would you have expected that? I would have not. So thank you for asking to simplify it. It was a very good choice. So the minimum cylindrical can has the same radius as height, with the smallest amount of material. Okay. Okay, let's look at something else. Let's read a couple of problems. They appear to be similar. I'm looking at 19 and 20. Let's check it out. Find a point on the line such and such that is closer to the origin. That's one option. The second option, find the point on the curve y equals the square root of x that is closer to the point 3, 0. Find the points on the ellipse that are furthest away from the point 1, 0. Find correctly two decimal places, really. The coordinates of the point on the curve y equals sine x that is closest to the point 4, 2. We've not seen anything like this before, so I think it's a good idea. You want to start with the point on the line, the point on the curve. Okay, the first one, 19. Okay, let's take a look at 19. Page 332. Find a point on the line y equals 2x plus 3 that is closest to the origin. What does that mean? The word closest means definitely find the smallest distance. So we want to minimize the distance between the line and the origin. Okay, I don't picture yet what's happening here, so let's take a look. That's the origin, of course. And now we want to graph this. When x is 0, we will always use x and y intercepts. When x is 0, how much is y? So 0, 3, 1, 2, 3. And now when y is 0, I move 3 to the other side, and I divide by 2. So negative 3 divided by 2. So x is negative 3/2. I connect and extend the line. I write on it y equals 2x plus 3. One more time, we read it one more time. So let's say, find the point on the line somewhere. I don't know. Let's say it's this. Of course it's not, but it doesn't matter. It's a point x comma, x comma. What is the y coordinate of this point? Right. So that is a point. Let's call it P. And I claim, of course I'm wrong according to the graph, I claim that once I determine this function and I minimize it, that will give me the exact position of the point. I specifically did not attempt to draw a perpendicular line. That's exactly where it is, right? It's going to be on the perpendicular line to this. That's the shortest line, the perpendicular one. But I specifically wanted to make a point, which means you cannot pick and choose. You have to say, this is a point P, generic point P. I could have used this P. Of course, that's going to be correct. So, but it's a generic point somewhere on the line. You cannot determine the coordinates. And minimizing that distance will give you the coordinates. So now let's write the distance, OP. Actually, I should have chosen something here so completely out of whack, so just to make a point. Okay, so then, what is the distance? If you remember, the distance formula is the square root y2 minus y1 squared plus, I should start with x, x2 minus x1 squared plus y2 minus y1 squared. Let's write that one. So x2 minus x1 squared plus y2 minus y1, everything squared. But this point has 0, 0, which is fine. So this is the square root of x2 minus x1 everything squared, fine, plus y2 minus y1 everything squared, fine. This is the function. Yes, I can clean it up a little bit. It's not important at this point. You'll see, because when I differentiate, I don't really look at the denominator. I needed to differentiate, but it's not gonna play any role later. So I determined a function. I have a function that represents the distance. Now, since I have the function, I have to do what? What would be the next step?
Differentiate.
Right. So let's differentiate this distance. It's a function of x. So when I differentiate, I get 1 over 2 the square root times the inner function prime. Have to be careful with that. So 1 over 2 the square root times 2x and plus plus 2 times 2x plus 3 times the inner function prime. 2. Okay, let's regroup and look at it one more time. Is this okay? So we created the distance. Is everyone okay with the distance formula? Yes? Okay. So now I created this distance function. It has only one variable. I don't have to worry about anything now. I differentiate 1 over 2 the square root times 2x plus this prime, 2x plus 3, 2 minus 1 times the inner function prime. So far so good? Okay, what is next? After I have the derivative, what would I have to do next? Yes, I will, and then set it equal to 0, indeed. So I will factor out a 2 that will eliminate this. So then I have x plus, but this one stays. So plus 4x plus 6. I don't need parentheses, I'm sorry, I should have not put them. But that's not a mistake, but there is no need. So now the numerator becomes 5x plus 6 over the square root of x squared plus 2x plus 3, everything squared. So it's completely cleaned up. There is nothing else I can do here, but I have to find the critical numbers. So I set this equal to 0. And of course, this doesn't matter. Only 5x plus 6 must be 0, so x must be negative 6/5. What is y? If x is negative 6/5, of course the y coordinate of the point, you already gave it to me as being 2x plus 3. So then I have 2 times negative 6/5 plus 3. So then y will be negative 12/5 plus 3, or y will be 15 minus 12, which is 3/5. So point P, we claim, we don't know that yet. We didn't show that. So we claim that the point P with coordinates negative 6/5 comma 3/5 guarantees a minimum distance. Is the point on the line that is found in the smallest possible distance from the origin. So this point P is not that, obviously. So it's negative 6/5, which is negative 1 and a little bit, somewhere there. And it has to have 3/5, which is roughly 0.6. My graph is not correct. So it should have been somewhere here. And obviously we expected that because it has to be perpendicular. That's the shortest distance. But we haven't shown that yet. So here we'll right now d prime of x, and we have here negative 6/5, and we have 0, and we have infinity, of course, and negative infinity. So we look at this function. This is the function, the first derivative. We don't care about this. This is always positive. Let's plug in 0 on the right-hand side. What do we get? when we plug in 0 at the top, I only need the sign.
Positive.
Very good. And now let's say I plug in -10. 5 times -10 plus 6, this doesn't matter. This is always positive. What will be the sign on this side? This is a typical situation for a minimum. So it's guaranteed now that this point is found at the shortest distance away from the origin, and it's a point on the line. But I have to show this to show that it's a minimum distance. Questions? How do we feel about optimization? Not too bad. Noah, you have a question? Go ahead.
Oh, no, I just always have trouble trying to find the equation.
The function?
Yeah, so once you get that, then it's easy.
Right. Once you get that, we differentiate, find critical numbers, and you study the sign. Yes. We have roughly 9 minutes left. We have plenty of time to at least attempt another problem, if that's okay with you. Would you like one in which the function is given, or would you like one in which the function is not given?
Nothing.
Not given. Okay, very good. We're going to stop in 9 minutes, promise. At least let's get it started. Okay. Something about the cost. A rectangular storage container with an open top is to have a volume of 10 cubic meters. The length of its base is twice the width. Material for the base costs $10 per square meter. Material for the sides costs $6 per square meter. Find the cost of materials for the cheapest such container. So which function we have to cheapest minimize here? Find the dimensions for the cheapest cost. The cost function. So we have to create a cost function, and we have to minimize it. So let's read the problem one more time. It has an open top, it's rectangular, the volume is 10 cubic meters. The length of the base is twice the width. Material for the base costs $10 per square meter. Material for the sides, $6 per square meter. Find the cost of materials for the cheapest such container. So 16 on 332. So here it is. The length is twice the width. So if this is x, which is the width, how much is this? Perfect. And this is the height. And the volume, they say it's 10 cubic meters. Can anyone give us the formula for the volume? So it is 2x times x, which is 2x squared times h. Very good. And this must be 10. So now let's analyze the cost. The base costs $10 per square meter. The sides, 6. So what is the area of the base? Good. Times the cost per square meter. So 2x squared times 10 plus. We have two sets of identical sides. One side is 2x times h times 2 because they're identical, and the other side is x times h times 2. And they all cost 6. And also 2, because there are two pieces identical. So what is the area of the front? Base times height. So 2x times, yes, and on the side, x times h, correct? So we have two of those. So we have 2x times h and plus, already put the 2, sorry. But this is okay. This is 2x times x and this plus x times h. As you see, I could not put c of x because it has another variable in there, which is h. So let's try to clean it up as much as possible. So this is 20x squared plus 12 times 2, 24xh, and plus 12xh. So this bothers me and this bothers me because I can't differentiate just yet. But I do have a piece of information that allows us to eliminate h. How do I eliminate h? From what I'm given here. Right. So right here, I solve this for h. And it's 10 divided by 2, which is 5 over x squared. All I need to do is just plug it in. So now it's indeed a function of one variable. 20x squared plus 24x times 5 over x squared plus 12x times 5 over x squared. Now, what is important here is if we understood the function and how we created it. Is this okay? Greg, is this okay? Please go back and
Try to figure out,
the function.
yeah,
Okay, let's take a look again. So this part is clear, correct? Area of the base, 2x times x, 2x squared, times the height. That's the body. So here we have the base. The area of the base is 2x times x, which is 2x squared. And if this is like 10 square meters, then we have to multiply by 10 because each square meter costs $10. So this would be the cost for the base. The area times the cost per square meter.
okay,
Now here we have, the base is not a square base. So then we have two sides, front and back, that have the same area. 2x times h. But there are two. So 2 times 2x times h times the cost per square meter. And now we have two more. We have x times h. There are two. X times h times the cost of 6.
okay,
Because all around this costs 6 per square meter and my base is 10.
okay,
And then we clean it up by distributing.
Right.
And from here we took h was 10 divided by 2x squared, but I simplified and I got 5 over x squared.
okay, I see.
Is that better?
Yep, thank you.
So I'm just going to stop here after we simplify this one more step. I'll simplify by x and then plus, is it 120 divided by x? And then simplify here and I get, is this 60 by x? Am I correct? So this is 20x squared plus 180 over x. And next time we're going to find c prime. We're going to find the critical numbers and then decide whether it's a max or a min or whatever. I just don't want to hold you. I have just one.